Now we're going to learn about the basic ingredients of climate research. In other words, what data should you use? When we're doing climate research, altering the climate to test a hypothesis is difficult and inadvisable. We might have an impact on the world that we can't reverse. So instead of doing this, we try to gain knowledge using a combination of observational data, numerical models, and reanalysis data. You're going to learn more about a particular data set when you're doing your own projects. But for now, we're going to give you a broad overview of the different types of data available. The first is observational data. This includes many different things, such as real-time data from, for instance, satellites or ocean buoys. These are needed for weather and ocean forecasting. Additionally, there's survey data, for instance, from ships or coastal maps, which is important for offshore data, things like nautical charts or fishing predictions. Then there's descriptive observations, such as drawings or verbal descriptions. These are useful for developing intuition and categorizing phenomena, as well as being the primary direct observation we have for any weather phenomenon more than maybe 100 years old. Lastly, we have proxy data, which are indirect measurements of variables from time periods without direct observations. So typically, we're talking about prehistoric time periods. Next, we have numerical models. These include idealized models, such as energy balance models. These contain the bare minimum physics necessary to reproduce a phenomenon and are useful for developing intuition about the underlying physical processes. There's also general circulation models, or global climate models, or just GCMs. These are useful for simulating the impact of climate change or just a broad range of different climates. They can, however, be computationally expensive to run, and some features are excluded from them because of limited computational resources. For instance, there are currently no GCMs that properly resolve clouds. Lastly, we have a wide range of intermediate complexity models, such as cloud resolving models and large eddy simulations. These can be used both to bridge the gap between idealized models and GCMs, and also to inform parameterizations for phenomena at smaller scales than GCMs can resolve. Lastly, we have reanalysis data, and I have put this into its own category because it's a sort of interesting combination of both observational data and models. The basis of it is observational measurements from the past 80 to 100 years, but where there are gaps in that data, reanalysis data uses models and forecasting to fill them in. This can give a more complete picture of historical weather and climate with some stipulations. One of the major ones is that it can be very large, but the size can be reduced by, for instance, selecting a few variables, taking averages, or focusing on particular time periods or locations. So when you're doing your own research, what data should you choose? I would recommend thinking about what you are trying to achieve with your research. If you want to explain the theory behind a phenomenon, an idealized or intermediate complexity model might help you the most. If you want to study a particular event or time period, observational or reanalysis data might help you more. If you want to simulate climates with very different features from present-day Earth, GCMs might be helpful, but also you can look to proxy data for some insight. For more information about choosing a data type, check out the notebook. We've included some additional resources for you there. So when we're thinking about our research question and studying the relationship between carbon dioxide and temperature, what basic ingredients should we use? The bare minimum necessary to capture the physics is what's called an energy balance model. GCMs can also be used to simulate climates with different atmospheric CO2 concentrations. Lastly, proxy data can be used to look at prehistoric time periods when the atmospheric carbon dioxide level was very different from the modern day. And for this little sample project, we're going to look at proxy data, more specifically, ice cores for data on atmospheric carbon dioxide levels, and deep sea sediment for data on sea surface temperature.